And it is time. What is up, everyone? Welcome back to my Twitch channel or my YouTube channel or my LinkedIn page, wherever you are watching this. My name is Tyler Ramsbey, and we are going to do some more hacking. And as some of you have noticed in the chat, yes, it is 3 days in a row. Don't know how many days in a row I'll do this, but I am just getting ready for the one and only Advent of Cyber event. So starting on December 1st through the Try Hack Me platform, they have a completely free event about cybersecurity, both on blue team and red team side of things, and it's called the Advent of Cyber. They have new beginner-friendly challenges every single day in December that follow a storyline. I am doing the official walkthrough for one of those days, but even outside of the day I'm doing the official walkthrough for, my plan, my goal, don't know if I'll do it, but my goal is to stream every single day through December, covering each one of those challenges. I think last year I made it through 14 days in a row. I'd have to double check. And then I took the OSCP. So I have a good excuse for why I stopped last year. Mid-December, I sat for the OSCP and passed it. But up until that time, I was streaming Advent of Cyber while studying for the OSCP and all that good stuff. So this year, I'm hoping in December, I can do it like every single day and see if we can make it through Advent of Cyber together. But for today, I don't know how long we'll stream. What I really wanted to do, let me get chat pulled up real quick. I wonder if can I throw LinkedIn on this side of the screen? And I'm going to throw Twitch. Okay, cool. Now I can see LinkedIn and Twitch. Perfect. What I really wanted to do this evening for however long, we'll see how long I do it, is I wanted to check out Web Security Academy's new Learning Pass. Let me go ahead and share my screen. I already have it all pulled up. They just announced this today. At least I'm pretty sure they announced it today. So Web Security Academy, if you guys have never used Portswigger Academy, really incredible resource to teach web app security. If anyone remembers the classic book, Web Application Hacker's Handbook, I think there's a version 1 and a version 2. The Web Security Academy, or Portswigger, is kind of like version 3, always being updated. One change they made, I believe as recent as today, are these Web Security Academy Learning Pass. Now, I'll be honest with you, I haven't done any of them. You can see I clicked it, that's why it shows one, but I didn't want to go through any of it without being on stream. I wanted to work through this together, go into it blind, and just give you my initial reactions to this. I'm hoping they might be making it a little more like Hack the Box Academy and Try Hack Me. Portswigger was already awesome, but it was a little bit confusing knowing which module to do, which path to follow, and I'm guessing this streamlines the process a little more to help you just dive right in and figure out what we can learn. The first learning path, there's only 2 right now, so when I was reading about it, they've only come up with these 2 learning paths, but they plan on adding more in the near future. These are more like an experiment to see how they go, and the first learning path is Server-Side Vulnerabilities. So I thought, hey, let's jump on stream and let's do this together. So once again, guys, this is completely free. I am going to use Burp Suite because Portswigger makes Burp Suite, and I am signed into my professional version of Burp Suite just because I know for some Portswigger labs, you do need some features that are only available in the professional version, but you should be able to follow along with most of it with Community Edition, or honestly, even with Cato. If you do Cato, I'll be able to let you know which one of these won't work in Cato because I'm pretty familiar with Cato and pretty familiar with Burp Suite. But like I said, going into it blind, let's see our initial thoughts and let's do some learning together. I need to refresh LinkedIn. Okay, LinkedIn is working. Sweet. LinkedIn's so weird. So guys, on LinkedIn, if I don't see your comments, I have to like refresh it each time to see the comments and questions. Daniel asked if I figured out the plugin. No, dude, I ended up just closing OBS. If anyone was on stream yesterday, I like told everybody bye on YouTube. But then like my weird OBS plugin I used to multi-stream disappeared and I couldn't figure out how to turn off my other stream. So like I couldn't get LinkedIn and Twitch to stop watching me. I had to just literally close OBS. Zach said, Tyler, what's your Discord? Here, I will. Well, actually, I don't have an invite link handy. If you just go to my YouTube page, Zach, and go to some of my past videos, you should see in the description an invite to my Discord. Would love to have you there. But okay, guys, let me get a drink. And let's go ahead and see what these learning paths are all about. I don't view progress. Let's see if I did anything. Oh yeah, I just clicked it. I didn't even read it. So let's resume learning. And we're on the very first thing. We're going to talk about path traversal, it looks like. So what I'll do is I'll read through this in its entirety. I will be your e-reader. I noticed, like with Try Hack Me Rooms and Hack the Box Academy, it helps to slow down and actually read everything so you don't miss the small details and then get yourself stuck. So I will be your audiobook, and we will read through this together. When we get to the labs, we'll go through the labs together. So what is path traversal? Well, path traversal is known as directory traversal. These vulnerabilities enable an attacker to read arbitrary files on a server that is running on an application. That might include application code and data, credentials for backend systems, and sensitive operating system files. In some cases, an attacker might be able to write to arbitrary files on the server, allowing them to modify application data or behavior and ultimately take full control of the server. All right. So reading arbitrary files via path traversal. So here's one thing I already notice that I like about Try Hack Me and Hack the Box Academy. I see we're going to get some code blocks here, but it's just giving us the code block. And then I'm guessing once we look at this, we'll do the lab. It would be helpful. No one from PortSwigger is probably going to watch this, but my only advice to PortSwigger is it would be helpful as we're given these examples to have a lab we can already do the examples in. So like we can look at the examples and do them at the same time, and then maybe the challenge lab builds upon that. But I like being able to do it as I read about it. So that's my first feedback right away. So reading arbitrary files via path traversal. Imagine a shopping application that displays images of items for sale. This might load an image using the following HTML. So we're doing an image source, and hey, here's our file. And I'm guessing this is where we're going to look at path traversal. Anytime you see file name, you want to try to test path traversal. The load image URL takes a file name parameter and returns the contents of the specified file. The image files are stored on a disk in this location. To return an image, the application appends the requested file name to this base directory and uses a file system API to read the contents of the file. In other words, the application reads from the following file path. This application implements no defenses against path traversal attacks. As a result, an attacker can request the following URL to retrieve the etc password file from the file system. Yep, and that's kind of what I assumed. This causes the application to read from the following file path. The sequence of .. is valid within a file path. It means to step up one level in the directory structure. The 3 consecutive sequences step up from var www images to the file system root, and so the file that is actually read is etc password. On Unix-based OSs, this is a standard file containing details of the users that are registered on the server, but an attacker could retrieve other arbitrary files using the same technique. On Windows, both forward and backslashes are valid directory traversal sequences. The following is an example of an equivalent attack on a Windows-based server. Cool, good stuff. Okay, you guys can see I've done quite a bit of PortSwigger when I was just learning, even in my continual learning, so it looks like I've already done this lab, but it was a long time ago. So we will do it again and see if we can figure it out together. So we will click Access the Lab. Okay. Try it again. There we go. Access the lab. Make sure I'm not missing anything in the chat. Curious, for those of you in the chat, have you done this yet? Have you checked out this new PortSwigger learning stuff here? Looking over at LinkedIn, Daniel said, is Burp Suite Pro one-time fee or a subscription? Unfortunately, my friend, it's a subscription. I don't even know the price. I know when I was first looking at it, it's $400 a year, so not terrible. They may have raised it a little bit in the past year or so, but I get it through work, so I don't actually pay for it. So here we go. File path traversal, simple case. So we have this shopping application. So that's cool. AZ Cowboy said, didn't even know they had an academy. Yeah, dude, and it is by far some of the best web app training you can get, and it's completely free. No subscription needed to their academy. Making sure I'm getting all the chat. All right, so we have all these images. If we go ahead and view details, we'll just click around it first. We have a pest control umbrella. What the heck is that? A pest control umbrella. That is awesome. All right, return to list. When we turn on intercept, what happens when we click view details? So we see we get a product ID of 1. If I throw that over to repeater, do we have anything interesting? Nope. So here we have our file name. You guys get that? So before it loads that file, send that to repeater. But you'll see it's trying to load this file. When I forward it, it's going to grab that file name. So here is our file name. And I'm guessing, I don't know why inspector just doesn't permanently go away when I close it once. Like, clear the inspector if I want you. Is there a way to hide that actually? Expand, collapse all. Whatever. Here is this. So I'm guessing if we do, well, what am I supposed to read, I guess? What's the challenge? Etsy password. All right, let's do Etsy password. There you go. We have read Etsy password. Usually, so with Portswigger Academy, there's usually not a flag. It's just once you do it, it solves the lab. But as you guys can see, I already solved the lab, so I don't think it's going to do anything different. But generally, if you're doing this for the first time, you solve the lab, and like when Portswigger sees you made this request, it will mark the lab as solved. And if we look at the solution, you can see pretty basic. Let's go ahead and do continue. So is this a no, this isn't a different one. Oh, I should probably turn off repeater A. That'd be a good idea. All right, access control. What is access control? Well, access control is the application of constraints on who or what is authorized to perform actions or access resources. In the context of web applications, access control is dependent on authentication and session management. So authentication confirms that the user is who they say they are. Session management identifies which subsequent HTTP requests are being made by that same user. And access control determines whether the user is allowed to carry out the action that they are attempting to perform. Broken access controls are common, and I will just highlight this. I see this in real web apps all the time and often present a critical security vulnerability. Design and management of access controls is a complex and dynamic problem that applies business, organizational, and legal constraints to a technical implementation. Access control design decisions have to be made by humans, so the potential for errors is high. Vertical privilege escalation. If a user can gain access to functionality that they are not permitted to access, and this is vertical privilege escalation. For example, if a non-administrative user can gain access to an admin page where they can delete user accounts, and this is vertical privilege escalation. Yep. Unprotected functionality. At its most basic, vertical privilege escalation arises where an application does not enforce any protection for sensitive functionality. For example, administrative functions might be linked from an administrator's welcome page, but not from a user's welcome page. However, a user might be able to access the administrative functions by browsing to the relevant admin URL. So I've seen this in a very real way in a web app. Actually, I saw it in a classic way where it was like just a cookie that admin equals yes or whatever, admin equals true, and that worked in the real world, and I was able to elevate my privileges. For example, a website might host sensitive functionality at this URL. This might be accessible by any user, not only administrative users who have a link to the functionality in the user interface. Also see this in the real world. In some cases, the administrative URL might be disclosed in other locations, such as robots.txt. Even if the URL isn't disclosed anywhere, an attacker may be able to use a word list to brute force, so you think GoBuster, Dirtbuster, Fearoxbuster, Fufuff, the location of the sensitive functionality. All right, we have our lab. You can see I already solved this one at some point in time in the past as well. I'm going to refresh LinkedIn so I'm not missing any comments there. Everything's good. YouTube is good. Okay, cool. So we have another lab. You can see I did this in some point in time. I don't remember when I did it, but it has an unprotected admin panel. We want to delete the user Carlos. All right, Carlos, you're going down, bruh. Get another drink while this lab loads. It's a lot of talking. Oh, and I lost LinkedIn. Hold up. There, LinkedIn, I got you back up. All right, we like to shop unprotected admin functionality. So if we look at our page, nothing too interesting here. If we go to my account, were we given creds to log in? Nope. So is the admin panel just like admin? Nope. Try robots.txt. Okay, so in robots.txt, we have this disallow administrator panel. And oh, it says lab not solved. So when we delete Carlos, it should solve the lab. So let's give that a shot. There we go. Lab is solved. We solved the lab. Congratulations, guys. Now this seems simple, but I kid you not, I do see this in the real world. Continue. Unprotected functionality continued. In some cases, sensitive functionality is concealed by giving it a less predictable URL. This is an example of so-called security by obscurity. However, hiding sensitive functionality does not provide effective access control because users might discover the obfuscated URL in a number of ways. Let me just pause here because in a bug bounty, it's more like guessing. But when you do an actual web app pen test, generally what a client will give you is different access levels. So if there's 2 access roles in an app, a user and an administrator, when I do a web app pen test, I request from the client, I want an admin user and a regular user, and then I'll use a Burp Suite extension called, I believe, Authorized. I don't have it on here. Let me pull it up for you guys. Or is it Authorized? Hold up. It's Authorized. Here we go. That's what I'm talking about. So I'll use this extension. And so Authorize is an extension aimed at helping the pen tester detect authorization vulnerabilities, one of the more time-consuming tasks. It basically allows you to put in the cookies of a low-privilege user, and then you navigate the website while logged in as a high-privilege user, and then every request that you make, it will try to make the same request with that low-privilege user token, and if it seems to succeed, it will notify you. So it kind of automates this process of looking for unprotected functionality via broken access control and privilege escalation. So this is what I will use in the real world, and we'll request those 2 different account types from a client, if that makes sense. Imagine an application that hosts administrative functions at the following URL. Okay. This might not be directly guessable by an attacker. However, the application might still leak the URL to users. The URL might be disclosed in a JavaScript that constructs a user interface based on this role. And this is where JS Miner, another extension I talked about yesterday, would come in helpful. So it's just saying, hey, here's a script asking, is admin? And if it is admin, we're going to set the attribute for the admin panel. The script adds a link to the user's user interface if they are an admin user. However, the script containing the URL is visible to all users regardless of their role. This lab has an unprotected admin panel. It's located in an unpredictable location, but the location is disclosed somewhere in the application. All right, let's check it out. Okay. Let's try that again. Here we go. Unprotected admin functionality with the unpredictable URL. So first, let's just refresh this page. Throw it over to repeater. And do we have anything interesting here? So nothing right there in the HTML. Obviously not YouTube, not Academy header. All right, and if we scroll through, like view details, we have my account, throw that to repeater, login, throw that to repeater. If we look at login, what do we have? Okay, so very similar thing. On the login page, we have JavaScript going. We're setting a variable is admin, and right here is false. If is admin, and we're just adding that admin URL to the user interface. But there we go. We have the admin panel. Turn that off. Go to our delete Carlos again, right? Yeah. Peace out, Carlos. Boom. We solved the lab. Congratulations, guys. Continue. Some applications determine the user's access rights for all login and then store this information in a user controllable location. This is what I was talking about before. A hidden field, a cookie, or a present query string parameter. This is actually what I saw in the real world, this one right here. The application makes access control decisions based on the submitted value. For example, insecure website, login, admin equals true, or role equals 1. This approach is insecure because, of course, a user can modify the value, never trust the user, and access functionality they're not authorized to, such as administrative functions. another lab. So this lab has an admin panel admin, which identifies administrators using a forgeable cookie. Solve the lab by accessing the admin panel and using delete Carlos, and we are Wiener Peter. Sounds good. Do. Here we go. Let's go to my account. Wiener Peter, that's my real login for my bank account. We'll hit login. So we see this going on, and we'll see if it sets a cookie. If we send it to repeater and close annoying inspector, look at that. We're setting a cookie called admin false. You guys see that? So now if we forward, I must have broken that by doing it in repeater first. We'll try that again. Wiener Peter, intercept, login, forward, admin, true. And we have admin panel. We could do a find and replace on this, but we'll just manually update it. Admin true. And then we can delete our friend Carlos. Again, we might have to set that again when we click delete on Carlos. Yep, that's right. Admin equals true. Forward. And we solved the lab. Congratulations again, guys. We're killing it. Let's do continue. Horizontal privilege escalation. This is lateral movement, right? From not elevating your privileges, but horizontal privilege escalation occurs if a user is able to gain access to resources belonging to another user. Think of IDOR instead of their own resources of that type. For example, if an employee can access the records of other employees as well as their own, well, then this is horizontal privilege escalation. Horizontal privilege escalation attacks may use similar types of exploit methods to vertical privilege escalation. For example, a user might access their own account page using the following URL, ID 123. If an attacker modifies the ID parameter, once again, see this in the real world pretty often, to that of another user, they might gain access to another user's account page and the associated data and functions. This is an example of IDOR. That's what I mentioned in the beginning. In some applications, the exploitable parameter does not have a predictable value. For example, instead of an incrementing number, an application might use globally unique identifiers or GUIDs to identify users. This may prevent an attacker from guessing or predicting another user's identifier. However, the GUIDs belonging to another users might be disclosed elsewhere in the application where users are referenced, such as user messages or reviews. All right, let's do another lab. So, to solve it, we need to find the GUID for Carlos, then submit his API key as a solution. Let's do it. Checking out chat. Don't think I missed anything. Yeah, guy on YouTube, Gerbage. I might be saying your name wrong. If I am, I'm sorry. But he said Carlos is going to have a terrible day at work. You're right, dude. We just keep deleting his accounts. That's rough. So we have some blog posts. I'm guessing Carlos left a comment, and maybe we can see it that way. That's my initial guess here. Let's see if we can look at some of these posts. Or maybe he wrote a blog. Or maybe what if I click administrator? So if we click administrator, it goes to the user ID. But how does it specify that? If I do this, oh, then automatically goes to the user ID. Okay, so it's not like putting in the admin and then giving it. So we have to find Carlos's name. He must have written one of these posts. Where you at, Carlos? Hey, there's Carlos. I told you guys. Oh, he wrote a few posts. Well, we only need one. So then if we get Carlos here, here's his user ID. We'll just send it over to repeater so we have it. We can do that. And if we go to my account, Wiener Peter, your API key is... Okay, so then it's just giving us based on the GUID up here. So if we grab Carlos's, and there we go. We got Carlos's API key. Submit solution. Boom. We solved the lab again, making Carlos have even a worse day at work. Continue. Horizontal to privilege escalation. Often, a horizontal privilege escalation attack can be turned into a vertical privilege escalation by compromising a more privileged user. For example, a horizontal privilege or horizontal escalation might allow an attacker to reset or capture the password belonging to another user. If the user targets an administrative user and compromises their account, then they can gain administrative access and so perform vertical privilege escalation. An attacker might be able to gain access to another user's account page using the parameter tampering technique already described for horizontal privilege escalation. So you can see 456. King Glizzy said Carlos is fighting for his life right now. Yeah, dude, I agree. He's just getting beat up on. If the attacker user is an application admin, then the attacker will gain access to an administrative account page. This page might disclose the administrator's password or provide a means of changing it, or might provide direct access to privilege functionality. All right, this lab has a user account page that contains the current user's existing password pre-filled in a masked input. To solve this lab, retrieve the administrator's password, then use it to delete Carlos again. Dude, he's just getting beat up. So hold up. It has an account page that contains the current user's existing password, pre-filled in a mask input. Retrieve the administrator's password. I don't quite even understand what it's asking, but let's see if we can figure it out. Probably make more sense when I see it. Okay, so was this on like my account or something? Or do I need to log in first? Or not Carlos. Wiener Peter. Oh, I see it right there. And we just go by ID Wiener. So what do we do on this request? If I hit login, and it tells me my username is Wiener. So can I see Carlos? The username is Carlos. So then is it administrator? Your username is administrator. Okay, so let's do that. Do hack smarter 123. My account. Log out. My account. Administrator. Hack smarter 123. Oh, that didn't actually work. Oh, whoops. I changed Wiener's password. Hack smarter 123. Okay, so if we look at this update password request, I'm just going to call it hello. Well, we'll do password 123 just so it's easy. We're doing a CSRF. We have our session. We're updating the password here. Maybe we can just copy and paste the password out of there. Or just modify the JavaScript. Hold up. I think I'm overthinking this. So, let's do home. My account. That's the password. You can just copy and paste it out of there. What? Maybe that's not the password. Wiener, password 123. Whoops. My account, administrator, forward. So I just want to make sure I'm not just pasting the same thing. So if I copy that. Oh, I can't copy it. So can I inspect? There's the password right there. So we'll copy that, log out, turn off intercept, my account, administrator, paste, boom, admin panel. Peace out, Carlos. Took me a little bit longer that time, Carlos, but we still got you, bruh. All right, continue. Authentication vulnerabilities. So we're moving to a new section. Conceptually, authentication vulnerabilities are easy to understand. However, they are usually critical because of the clear relationship between authentication and security. Authentication vulnerabilities can allow attackers to gain access to sensitive data and functionality. They also expose additional attack surface for further exploits. For this reason, it's important to learn how to identify and exploit authentication vulnerabilities and how to bypass common protection measures. In this section, we explain the most common authentication mechanism used by websites, potential vulns in these mechanisms, inherent vulns in different authentication mechanisms, typical vulnerabilities that are introduced by their improper implementation, and how we can make our own authentication mechanisms as robust as possible. What is the difference between authentication and authorization? Well, authentication is a process of verifying that a user is who they claim to be. Authorization involves verifying whether a user is allowed to do something. Get that, like if you guys are preparing for cybersecurity interviews, make sure you get that definition in your head because you will be asked about the difference. For example, authentication determines whether someone attempting to access a website with the username Carlos123 really is the same person who created the account. Once Carlos123 is authenticated, the permissions determine what they are authorized to do. For example, they may be authorized to access personal information by other users or perform actions such as deleting another user's account. We're going to delete Carlos's account again, guys. I'm calling it. A brute force attack is when an attacker uses a system of trial and error to guess valid user credentials. These attacks are typically automated using word lists of usernames and passwords. Automating this process, especially using dedicated tools, potentially enables an attacker to make vast number of login attempts at high speed. Brute force is not always just a case of making completely random guesses at usernames and passwords. By also using basic logic or publicly available knowledge or password rules like in Hashcat, attackers can fine-tune brute force attacks to make much more educated guesses. This considerably increases the efficiency of such attacks. Websites that rely on password-based login as their sole method of authenticating users can be highly vulnerable if they do not implement sufficient brute force protection. Usernames. Brute forcing usernames. Usernames are especially easy to guess if they conform to a recognizable pattern such as an email address. For example, it is very common to see business logins in this format, first name, last name, at some company. However, even if there is no obvious pattern, sometimes even high-privileged accounts are created using predictable usernames such as admin or administrator. During auditing, check whether the website discloses potential usernames publicly. For example, are you able to access user profiles without logging in? Even if the actual content of the profiles is hidden, the name used in the profile is sometimes the same as a login username. You should also check HTTP responses to see if any email addresses are disclosed. Occasionally, responses contain email addresses of high-privileged users such as admins or IT support. Passwords can be similarly brute forced, with the difficulty varying based on the strength of the password. Many websites adopt some form of password policy, which forces users to create high entropy passwords that are, theoretically at least, harder to crack using brute force alone. This typically involves enforcing passwords with these things. The one thing that we do when we're doing an engagement, especially an external engagement, is we will look at passwords that have been breached in various breaches, and we will do password spraying attacks on login portals. So if your employees have reused their password, which they often do, we got you. However, while high entropy passwords are difficult for computers alone to crack, we can use a basic knowledge of human behavior to exploit the vulnerabilities that users unwittingly introduce to the system. Rather than creating a strong password with a random combination of characters, users often take a password they can remember and try to crowbar it into the password policy. For example, if my password is not allowed, users may try something like my password 1 exclamation mark or my password. You know, that's no hacker would ever guess that. In cases where the policy requires users to change their passwords on a regular basis, it is also common for users to just make minor, predictable changes to their preferred password. For example, my password 1 becomes my password 1 question mark or my password 2 like exclamation mark period. This knowledge of likely credentials and predictable patterns means that brute force attacks can often be much more sophisticated and therefore effective than simply iterating through every possible combination of characters. Overgrown Carrot just said, just uninstalled OBS, the other one, and downloaded Studio, added the plugin, and we'll try to stream to Twitch, YouTube, and LinkedIn tonight. Sweet, dude. So Overgrown Carrot, I know we are in different time zones. How many hours from now will you be streaming? Would love to come join you, unless it's like the middle of the night for me. Let me hit continue here. Brute force, or username enumeration. We actually talked about this on my stream yesterday. We found this. Username enumeration is when an attacker is able to observe changes in the website's behavior or to identify whether a given username is valid. A username enumeration typically occurs either on the login page, for example, when you enter a valid username but an incorrect password, or on registration forms when you enter a username that is already taken. This greatly reduces the time and effort required to brute force a login because the attacker is able to quickly generate a short list of valid usernames. When attempting to brute force a login page, you should pay attention to these things. Status codes. During a brute force attack, the return HTTP codes are likely to be the same for the vast majority of guesses, right? We'll do that. Error messages, that's kind of self-explanatory. And this is actually what I shared on stream last night, is response times. I've seen this in real web apps where error messages are generic, status codes are the same, but you can discern valid users by response times. If most of the requests were handled with a similar response time, any that deviate from this suggest that something different was happening behind the scenes. This is another indication that the guest username might be correct. For example, a website might only check whether the password is correct if the username is valid. The extra step might cause a slight increase in the response time. This may be subtle, but an attacker can make this delay more obvious by entering an excessively long password that the website takes noticeably longer to handle. The way I saw this in the real world is it was a password reset functionality, return a generic error message, but for valid accounts, it took the time to send an email before responding. You couldn't notice it in the GUI, but by watching it with Intruder and then looking at response received, response completed, I could see which usernames were valid and which ones were not valid. Everyone cares at around 8 hours. Well, I might just be waking up for the morning. I might watch you in the background. My kids can watch you too, but that sounds good, dude. Either way, I'll catch the recording afterwards. All right, user enumeration via different responses. Okay, this is really cool. I'm happy that we have a lab about this because I've been talking about this the past couple of days. We have our usernames here and our passwords, and we'll use Intruder in order to do this, and I'll show you guys how we are going to do this. So let's go ahead and access the lab. AZ Cowboy said, future Audible career. Dude, I kid you not, when I was a pastor and, made like $30,000 a year for a family of 4, I actually looked into recording like audiobooks and things like that to make some cash on the side. I never ended up going through with it. I don't remember why, but I always thought that would be fun. I really do enjoy reading. Like when I'm not hacking, guys, or hanging out with my family, I'm reading books. Really do enjoy reading. All right, let's go to my account. So you can copy paste the file on this of Burp Intruder to help you solve the authentication labs. And we have this. So first we'll enumerate a valid user, then a password. So do a valid user, we'll do Hack Smarter first, and password can be whatever, test, whatever we want. We'll turn this on. We'll go ahead and send this to Intruder. We have Intruder here. We will mark our username tab, click add, go to payloads, grab this. Here's the part that if you don't have Burp Suite Pro, it's going to be a little bit annoying because you're rate limited, but you could do the same attack in Cato and you wouldn't be rate limited. But let's go ahead and copy this, paste that into there, and hit start attack. Okay, so notice, guys, they're following seemingly best practices. We have the same status code being returned. We have the same length being returned. Right now, there's no way to discern whether or not a username is valid, but what we can do is if we do column and response received and response completed, I don't remember which one I usually look at after the same thing. If we sort it this way, maybe it's response received. So we have multiple, it's kind of hard to discern, I guess, unless we go down here. I don't know if test is going to be the proper one. Test has a higher response, but there's nothing like that obvious here. When I saw this in the real world, it was really obvious whether or not a user was going to be valid. I just want to make sure I'm looking at the right thing too. Enumerate a valid username, brute forces user password, then access their test account. And it's based on response times, right? So I'm guessing it's either test or info. That would be my guess if we go ahead and we can keep that in memory. We'll do this proxy here. We'll change this over to test. And now we will go ahead and send this to intruder. Make sure our password is highlighted. We'll go over to payloads. And now we have all of our passwords here. Copy that. Paste that. That all looks good to me. And hit start attack. Nope, maybe we're not going to get it that way. So it's just user enumeration via different responses, but I'd assume response time. You see, we don't have anything too interesting here. Let's think about if we go back to this brute force attack. Let's make our password way longer. Hello, stream. Maybe this will cause it to be more obvious. Okay. Is it status code? I feel like I'm doing something obviously wrong here. This lab is vulnerable. Maybe I'm looking at the wrong spot. Hold up. Let's just check that. Enumerate a valid username. Was the length different, AZ Cowboy 1? Was I just blind and I skipped over that? I thought all the length was the same. Oh, shoot, you're right, dude. It is the length. Good call. For some reason, I had it in my head that they were doing response times, but they weren't. If they were doing response times, that is how you check response times. But it is the length. You can see it here. So we know the valid username is Ann. So we can discard that. If we go over to this one, change our position or our payload, we'll change that to Ann. And start attack. And then we see that's our password. 1, 2, 3, 6 zeros. 1, 2, 3, 4, 5, 6. Hit login. All right, we solved the lab. Would have been cooler, guys, if it was response time. I'm just saying. But that's okay. We can discard this and make sure my proxy is turned off, and that's good there. Let's continue. Bypassing 2FA. There's actually a good Try Hack Me room that does this. I live streamed it. I don't remember what it is though. At times, the implementation of 2FA is flawed to the point where it can be bypassed entirely. If the user is first prompted to enter a password and then prompted to enter verification code on a separate page, the user is effectively in a logged in state before they've entered the verification code. In this case, it is worth testing to see if you can directly skip to logged in only pages after completing the first authentication step. Occasionally, you will find a website doesn't actually check whether or not you completed the second step before loading the page. All right, let's go ahead and do this. Our 2FA can be bypassed. You've already obtained a valid username and password, but do not have access to the user's 2FA verification page. To solve the lab, access Carlo's account page. All right, Carlos is going down again. All right. He is going to go down eventually. So let me just see what the login flow is. We do login, we pass the username, password, forward. We do a login too, so is this where it's going to prompt for 2FA? And then we're asking for a 4-digit security code. I mean, that itself can be brute forced, like quickly. But like it said, we're already logged in at this one. I don't know if we can do. Not found. Oh, the email client has a 2FA code. But look, we're logged in. I didn't even answer the 2FA question. And if we open up the email client, it must have the 2FA code. 0049, but we could just fully brute force that as well. I might try to solve this lab in 2 ways just to see if it works. We'll go my account, and it says we have his credentials. Okay, so that's his password. So if I just do this, and what if I just drop that one? There, I solved the lab. It logged me in. But I want to do it a different way now. Let's see if we can brute force it. So if we do Carlos and then his password again. So Carlos, that 4-digit 2FA is not secure. So if we hit login, forward, and then we have this login too. And we have the security code. If we do login here and we send that over to intruder, we highlight this, do add, go to payloads, change it to numbers. We'll go from 000, we'll do 000 to 999 by steps 1, minimum digits of 4, and then we'll hit start attack. Oh, I can't do this because it tells me I solved the lab. Anyways, that's how you would brute force it. MFA code that's only 4 digits. Maybe we'll do that in one of these labs, and I might just be getting ahead of it. So let's click continue. Oh, no, I guess we're not going to do it. It is, I'm pretty sure they have a lab on that, though. But SSRF. A little hint, guys, when I do Advent of Cyber, this is the theme that I will be talking about. So that's my little preview for you guys. What is SSRF? Server-side request forgery is a web security vulnerability that allows an attacker to cause a server-side application to make requests to an unintended location. In a typical SSRF attack, the attacker might cause a server to make a connection to internal-only services within the organization's infrastructure. In other cases, they may be able to force a server to connect to arbitrary external systems. This could leak sensitive data such as authorization credentials. Is Port Swigger free to prepare for Burp? It is, but you will need Burp Suite Pro to take the exam, but you can get a free 30-day trial to Burp Suite Pro, I believe. SSRF attacks against the server. In an SSRF attack against the server, the attacker causes the application to make an HTTP request back to the server that is hosting the application via its loopback network interface. This is typically involves supplying a URL with the hostname like 127.0.0.1, a reserved IP, or local host. For example, imagine a shopping application that lets the user view whether an item is in stock in a particular store. To provide the stock information, the application must query various backend REST APIs. It does this by passing the URL to the relevant backend API endpoint via front-end HTTP request. When a user views the stock status for an item, the browser makes the following requests. We have a stock API, and yeah, if we replace that with localhost, this causes the server to make a request to the specified URL, retrieve the stock status, and return this to the user. In this example, an attacker can modify the request to specify a URL to the server. The server fetches the contents of the admin URL and returns it to the user. An attacker can visit the admin URL, but the administrative functionality is normally only accessible to authenticated users. This means an attacker won't see anything of interest. However, if the request of the admin URL comes from the local machine, the normal access controls are bypassed. The application grants full access to the administrative functionality because the request appears to originate from a trusted location. Yo, we have Carlos in the YouTube chat. Carlos, I apologize for deleting all your accounts, my friend. Continue. SSRF continued. Why do applications behave in this way and implicitly trust requests that come from local machine? Well, this can arise for various reasons. So one, the access control check might be implemented in a different component that sits in front of the application server. When a connection is made back to the server, the check is bypassed. For disaster recovery purposes, the application might allow administrative access without logging in to any user coming from the local machine. This provides a way for an administrator to recover the system if they lose their creds. This assumes that only a trusted user will come directly from the server. You know what happens when you assume? The administrative interface might listen on a different port number to the main app and might not be reachable directly by users. These kind of trust relationships, where requests originating from the local machine are handled differently than ordinary requests, often make SSRF into a critical vulnerability. All right, so to solve this lab, change the stock check URL to access the admin interface and delete Carlos again. Sorry, Carlos. Oh, whoops. Let's try this again. Another drink, too much talking. All right, view details. Check stock. I see our stock API there. Repeater. Wonder if we have to URL encode it. Haha, there he is. We're coming for you, Carlos. Okay, we're not coming for you yet, Carlos. Don't know. Oh, I see. So we need to lead him this way. I see what we need to do. Admin delete username Carlos. Send. Follow direction. Unauthorized. I think we solved the lab. Yep, Carlos has been deleted. Peace out, dude. Lab is solved. Continue. SSRF attacks. I'm laughing at the real Carlos in YouTube chat. SSRF attacks against other backend systems. In some cases, the application server is able to interact with backend systems that are not directly reachable by users. These systems often have non-routable private IPs. The backend systems are normally protected by the network topology, so they often have a weaker security posture. In many cases, internal backend systems contain sensitive functionality that can be accessed without authentication by anyone who is able to interact with the systems. In the previous example, imagine there is an administrative interface at the backend URL admin. An attacker can submit the following request to exploit the SSRF vulnerability and access the administrative interface. Yep, got it. Continue. Against another backend system. So to solve this lab, use the stock check functionality to scan the internal range for an admin interface on port 80, then use it to delete the user. Okay, I actually want to try something. I wonder if this will work on a port swigger lab. Let's give it a shot. This is a cool tool. I've only played around with it, so I want to show it to you guys. Okay. Let's see if this works. So view details, check stock. One 192.168. Copy that, go here, drop our request in there, and then if we do Python 3 SSRF map, should just be, what did I call it? Request.text, Python 3 SSRF map. I don't know why it's not auto-completing there. Whoa, whoa, okay, stop. Stop freaking out, bruh. I just want to see if it's reading my requests. .text -p URL -m port scan. Oh, that wouldn't be scanning the host. That's just scanning the port, though. So that actually wouldn't do what the lab's asking us. This would just see what ports are open, but it's not working anyways. Oh, P is like the injection point. See, I told you guys I've only played around with this. So the injection point would be stock API. I did not mean to do that. So here's one of the things you can do when you do have SSRF. What this is doing is probably not going to work because the lab isn't set up in this way, but it's scanning that specific server, and it would tell us, hey, here are ports that are open internally that aren't public facing, so we know it might be running. But like I said, it's not going to work for this lab. I don't think it has a module for scanning the full different IPs, just ports, I think. So we'll use burp intruder to do it. Just thought that would be cool. Can we see what modules we have? Let's look at their GitHub. Modules. We have RCE, SQL command, scan top 8,000 ports for the host. Oh, network scan. It should be ping sweep over the network. Let's try that. Never used it. Will it work? Is there like a verbose mode so I can see if it's actually doing something? Oh, there is. Let's do verbose mode. I want to see what it's doing. Okay, that obviously didn't do anything. Let's let that run while we do it ourselves with Port Swigger. Just curious if that's going to work. We can close this out. So then what we can do is we can literally just send this to intruder. And we need to set it to port. I think it said 8080, right? Like that. Range for an admin interface on port 8080. So then if we go to payloads and we change this to numbers, we can go from 0 to 9. That's all you'd have to do, I think. From 0 to 9 at steps of 1. So these all get a 500 error. The only 400 is the 1, but isn't that the one that was already there? Oh, what's this? I wonder if PortSwigger doesn't like me using a tool like this to try to scan it. Alright, we'll stop that tool. Okay, what's this saying? A missing parameter? So is that the IP range we're looking at? Just be 1 to 9. And then use it to delete the user Carlos. So then are we getting a hit on here and we need to delete our Carlos user? Oh, we need to add admin. Let's try that real quick. Discard. Something like that. Oh shoot, I think I broke it. Okay. Maybe I didn't break it. Check stock to see if this works. Alright, so that works. Oh no, so that gets internal server error. Cannot connect to external stock check. Okay, maybe that's what I need. And now if we send this one to intruder and then do our payloads, and we'll do numbers 0 to 9 at steps of 1. We don't need to URL encode anything, and hit start attack. Well, that didn't work either. All the same lengths. This doesn't really matter here. Cannot connect to external stock check service. And let's make sure our request is doing what we think it is. Oh yeah, I don't know why I'm doing 1 to 9. Good call, Izzy Cowboy. I don't know why I was thinking in my head counting to 10. Yeah, this is probably the only issue. The rest, I think admin can stay the same. Let's do this. Should get a different status code. And this is where, once again, community edition isn't going to be helpful. Yeah, I do have the brute force 2FA stuck on my head. Let me refresh LinkedIn since I can never see comments there. Do we have anything? Nothing? Okay, let's try changing this. Let's just see if we can hit the IP that way. Can I just up this resource pool? Oh no, I guess I'll keep it as that. It doesn't take too long. If this doesn't work, I'll just look at the community thing, because I'm sure it's something really silly I'm just not doing. Do. Not looking very promising. That's all it was, right? That one, that range right there. Does it need to be like URL encoded or something? All right. It's a 255 because I didn't check that. That wouldn't make sense though. All right, we'll just do it their way. Maybe that's the only thing I did wrong. Oh, but they have admin. Although I did admin the first time and thought I had to remove it. Oh, dude, do I have a freaking typo in the actual IP? Oh my goodness. Oh man. Yeah, that's all it was. The importance of starting simple, right, when you're troubleshooting. I just typed the IP wrong. Silliness. And it's 117. Like that. Yep. That's what it is. And delete Carlos. Oh shoot. I need to actually do that in the request. So we need to take that, bring it over to this, and then do the request. And then that should solve the lab though. If we just back out of here. There we go. Took me a second there because I don't know how to type IPs. But we did it eventually. Let's keep on going. File upload vulnerabilities. File upload vulnerabilities are when a web server allows users to upload files to its file system without sufficiently validating things like their name, type, contents, or size. Failing to properly enforce restrictions on these could mean that even a basic image upload functionality can be used to upload arbitrary and potentially dangerous files instead. This could include server-side script files that enable remote code execution. In some cases, the act of uploading the file is in itself enough to cause damage. Other attacks may involve a follow-up HTTP request for the file, typically to trigger its execution by the server. And guys, before we dive into file upload vulnerabilities, let's take a 5-minute break, if that's cool. 5-minute break, and then we'll dive in. I don't know if we'll finish this entire thing, but we are close. I don't know how much is on OS command injection and SQL injection, but I don't know. Let's see if we can. We're at 31 to 51. So maybe we'll finish this entire learning path in one stream. But in the meantime, let's take a 5-minute break. Guys, I will be back in 5 minutes. Stand up, jump around, do those things. BRB.